ሰላም እንዴት ናችሁ? ዛሬ በኤግዚት ኤግዛም ሶሉሽን ተመልሻለሁ። ስለዚህ በቀጥታ ወደ ጥያቄዎቹ ከመሄዳችን በፊት ምናልባት ለዚህ ቻናል አዲስ የሆናችሁ ሰዎች ካላችሁ ሰብስክራይብ በማድረግ እንድትጀምሩ ጠይቃለሁ። ስለዚህ ካልኩ በኋላ ወደ ጥያቄዎቹ እንሄዳለን። የመጀመሪያው ጥያቄ ካልኩለስ ሊሚት ነው። It says what is the value of limit 3 the power of x minus 1 over x. And then the alternatives are here. We know that there is a rational function containing an exponential term. So that directly, if we assume that the limit of the numerator and the denominator separately, or directly substitute 0 for x, we have this one that's simply 0 over 0, which is an indeterminate form. Therefore, applying L'Hopital's rule, differentiating the top, that is the denominator, and the denominator, that is the bottom function separately, we have this one that's simply derivative of the denominator, 3 the power of x minus 1 is equal to 3 the power of x times ln 3, and the derivative of the denominator, that is d by dx of x is 1. Therefore, its derivative will be 3 the power of x ln 3 over 1, so that its limit will be 3 the power of 0 ln 3, which is ln 3. And that means we know that L'Hopital's rule stated that if the limit of a rational function of this form has an indeterminate form that is either 0 over 0 or infinity over infinity, so that the limit of the original rational function is exactly equal with the limit of its the quotient of its derivatives, so that there is the answer, which is the answer. Therefore, the answer is alternative C, which is ln 3. Next, question number 2. Consider the function f of x equal to the absolute value of x over x. And then we have these alternatives. The first one is limit of f of x when x approaches 0 from the right side is equal to 1. Or the limit of the same function from at 0 from the right side is minus 1. Sorry. Therefore, if we check, for example, the right-hand limit, that is whenever x greater than 0, or simply x approaches to that the 0 from the right side, we know that whenever x is a positive real number, or within this interval that is x greater than 0, the absolute value of x is x, so that f of x will becomes x over x, which is 1. Therefore, its limit the limit of the function from the right side becomes 1, and from the left side, the absolute value of x is negative of x, so that f of x will be minus x over x, which is minus 1. And if we compare it contrasts, the function, since 1 is different from that of minus 1, then generally the limit doesn't exist at 0. That means the limit of the function at f of x whenever x approaches 0 from the right side is 1. Yes, of course, but the limit of f of x from the right side is not minus 1, but the limit of f of x does not exist because the limit of the function from the right side is positive 1, and from the left side it is minus 1. So that these two are not equal. Therefore, the function generally, the limit of the function generally doesn't exist. Therefore, the alternatives for the answer for this one could be A, and that of this one, that's simply C. Question number 3. We have if y is equal to the power of x, then y by dx is blank. That's the derivative of y with respect to x. And the alternatives are here. So let us find directly the derivative of the given function. For any exponential function, we have to know this one, that's simply function a the power of u. The derivative is a the power of u, that is the function itself, multiplied by ln of the bit, that's simply a, times the derivative of u prime, which is just chain rule. Therefore, if we apply this derivative rule for the given function, we have here a is 2 and u is x, so that u derivative will be 1, that is dx by dx. And the dy by dx is equal to the power of x, because a the power of u is given here, times ln 2 multiplied by the derivative of u, which is x, that is 1. Therefore, the answer could be alternative C to the power of x ln 2. So that's simply this one. Next question. We have what is the value of the integral x over the square root of x squared x. So that we may have different techniques for finding the derivative of this function. For example, we can easily trigonometric substitution or normal substitution here. So that, for example, if we apply substitution, integration by substitution, let's assume that the radicand from the denominator, that's 1 plus x squared du, and then du is equal to, taking the derivative of both sides of this function, we have 2x dx, or the x dx, that is simply the denominator, would be replaced by 1 over 2 du. And therefore, if we substitute the function that's simply u as a function of u, we have 1 over 2 du is already x dx, and the denominator is the square root of u, because we are letting u to be 1 plus x squared, so that is equivalent to 1 over 2 times, 1 over 2 times the integral of u to the power of minus 1 over 2, because 1 over the square root of u is u to the power of negative 1 over 2 du. So that the antiderivative, or simply the integral of this one, could be 1 over 2. We have to bring this one, that's simply minus u to the power of minus 1 over 2 plus 1 over minus 1 over 2, so that we can further simplify this one into 1 over 2 into 2 times u to the power of 1 over 2 plus c, or these two can be cancelled by this one, and we are left only with the square root of u plus c. But u is let to be 1 plus x squared, so that if we use back substitution, we have the square root of 1 plus x squared plus c, wherever c is any constant. Therefore, the right answer for the integral of this one could be, I think that's simply b, which is this one, which is the square root of 1 plus x squared plus c. Next question. It is complex analysis. The value of the modulus, or simply the absolute value of 1 plus I, is it's just blank. So definition for a complex number z is equal to a plus bi. The modulus, or is the square root of that, the norm is the square root of a square plus b square, that is the square root of the sum of its real and imaginary parts. Therefore, what we are given here is that the real part is 1 and its imaginary part is also 1, so that its norm could be the square root of 1 square plus 1 square, which is equal to the square root of 1 plus 1, which is radical 2. So that the alternative containing this one, that's radical 2 PC, therefore the correct answer is C. Question number 6. The polar form of z is equal to 1 plus I is, we know that in order to find the polar form of the given complex number, we have to take the R, which is the modulus of the given complex number, and its argument. We have R is equal to 1 plus I, which is equal to 1 radical 2, that is 1 square plus 1 square, just we have simple value there. And the argument, or simply theta, could be, it is just by using the formula theta is equal to b over a, so that 1 over 1, which is equal to 1, since z is in the first quadrant, because both the real and the imaginary part of the given complex are positive, so that theta will be an acute angle which is pi over 4. Therefore, if we combine the argument and the modulus, that's simply r of this complex number, we will obtain the polar form of the given complex number. That is simply general form of complex number could be r is equal to, z is equal to r times cosine of theta plus I sine theta. Therefore, if we substitute pi over 4 for theta and radical to for r, we have the result that simply z is equal to radical to into cosine of pi over 4 plus I times sine of pi over 4. And this could be obtained or simply contained in the alternative that's simply A. Question number 7. If f of z is equal to u plus iv is analytic, then which of the following alternatives must be satisfied in the question? So that let us see this definition first. We know that Cauchy-Riemann equations are a necessary condition for a function to be differentiable or analytic at a point. Therefore, the condition that simply the partial derivative of the real part with respect to x must be equal with the partial derivative of the imaginary part with respect to y. That is, Vx is equal to Vy. They hit the first necessary condition. And the second condition could be the partial derivative of the real part with respect to y must be equal the negative partial derivative of the imaginary part with respect to the x, that is uy is equal to negative ux. Therefore, the alternative which contains the combination of these two conditions where ux is equal to vy and uy is equal to negative vx is I think the first one, that is simply A. That is Ux is equal to Vy, which is this one. And the next one is Uy is equal to negative Vx. Therefore, the correct answer for this question is A. Okay, question number 8, which is algebra part. Which of the following is not a group? So in order to determine or simply just know which alternative doesn't form a group, let us see the requirement or simply the condition for a given set with its corresponding binary operation to satisfy a group. So that the group requirements are a closure property, that is the given set with respect to the given operation must have a closure property, associativity property, existence of identity. If there is an identity within the given set or simply expected group, its inverse must also be there, so that if the given set is satisfying these 4 conditions, so that the given set with respect to the given binary operation will satisfy to be a group. Therefore, if we analyze choice C, that's simply this one, Z with respect to multiplication. The identity is 1, because 1 is a multiplicative identity. But if we check the inverse for an element like 2, an element of Z, the multiplicative inverse of this one, that is 2, is 1 over 2, but 1 over 2 is not or simply cannot found within the set of integers, so that the the last requirement for group requirement, that simply this existence of inverse fails to be satisfied. Therefore, since 1 over 2 is not an element of Z, most elements do not have an inverse within the sets. Thus, it is a monoid, or simply it is not a group. That is, this point Z with respect to multiplication cannot satisfy to be a group. Therefore, the answer for this question could be at this point, that's simply C. But if you check the other, for example, that's simply A, we know that there is an additive identity. Every element within the set of integer has an additive inverse, which is the opposite of it, its opposite. Associativity property with respect to addition is satisfied. closure property, because the sum of any two integers is also an integer. Therefore, all the group requirements will be satisfied by this one, so that Z with respect to plus can satisfy is a group by itself. The same holds true for the case of rational number with addition and positive real numbers with respect to this one, that's simply multiplication. Next question, the inverse of the matrix A, which is this 2 by 2 matrix. The first row is containing 1 and 2, and second row is 3, 4, is, we know that in order to calculate the determinant of the given matrix, first we know that we were asked just to calculate the inverse of this matrix, so that in order to calculate the inverse of the given matrix, we need to find its determinant. First, the determinant must be non-zero. That is, the matrix itself must be invertible. So that in addition to finding the determinant of the given matrix, we need to find also its adjoint matrix or adjugate matrix. Then the inverse could be the product of the reciprocal of its determinant multiplied by the adjoint of the given matrix. Therefore, the determinant of this one could be, since it is by 2 by 2, the product that becomes the difference between the product of the diagonal element, so that 1 times 4 minus 2 times 3, which is 4 minus 6, which is minus 2. Therefore, it's different from that of 0, so that the matrix is invertible. Then, in order to find the adjugate matrix for a 2 by 2 matrix, A, B, and C, D, the adjugate matrix will be obtained in this pattern. That, for example, in the first one, that's simply the matrix, or simply the element, which is, in order to find the adjoint of this one, we have to relate the first row in the first column of this one, and we have to take the signed determinant of the remaining components, or simply the matrix which is obtained by the remaining components of the matrix. Therefore, what is remaining here is only D, and this is A11. So that's minus 1 to the power of 1 plus 1 is 2. So it's positive there, so that it becomes D. The same procedure will be applied just to determine the other elements are related to B, C, and that of D, so that it is just like this. Therefore, the adjoint of this one, that's simply 4 minus, the adjoint of the given matrix, that is 1, 2, 3, 4, could be 4 minus 2 and minus 3 positive 1. Then, applying the inverse formula, that is the inverse is equal to 1 over the determinant of A multiplied by the adjoint of A, so that it becomes 1 over negative 2 into 4 minus 2 minus 3, 1, so that the heat equivalent with, if we multiply that, simply distribute this one, each and every element of this matrix is multiplied by the reciprocal of the determinant, so that we'll obtain minus 2, that is 1 over negative 2 times 4 is minus 2, minus 2 times negative 1 over 2 is positive 1, and minus 3 times negative 1 over 2 is 1.5, which is positive, and this could be the negative 0.5. Therefore, this could be the inverse of this 2 by 2 matrix. Okay, question number 10, which is a question related to that of ring 12. A commutative ring with identity and no zero divisor is called a commutative ring with identity and no zero divisor is called. So let us see this definition first. An integral domain is a specific type of ring. An integral domain is a specific type of ring, and the property could be, it must be commutative under multiplication, and second property must be, it must have multiplicative identity usually denoted by 1, since the operation is multiplication. And the last one, that simple set would be, it has no zero divisor. That means if A is equal to 0, then either A is equal to 0 or B is equal to 0. If the product of any two elements within the given set is 0, that means. Therefore, this condition could be just asked here in the question form. Therefore, a commutative ring with identity and no zero divisor is called, it's just an integral domain, because all these properties are then satisfied by the integral domain. Therefore, the correct answer is B, which is integral domain. Question number 11. Which of the following is a subspace of R cubed? So in order to answer this one, we have to first see the criteria for the subspace of a certain vector, or simply a certain space that's simply R cubed. The criteria that it must contain the zero vector, that is the first one, that simply the space itself should contain this one, so that the subspace must contain this one, and be closed under addition and scalar multiplication. The subspace must be closed under addition and scalar multiplication with these two operations, so that when we analyze, for example, the first one, it's just if you check the existence or the inclusion of 0, 0 within this one, that is whenever x, y, and z of z 0, it becomes x 0 plus 0 plus 0 is equal to 1, which is different from that of 0, so that does not contain a zero vector. Therefore, A cannot be the subspace of R cubed. Similarly, B, when we check B 0, 0, and Z is holds so that it presents a line through the origin, which is closed under addition or multiplication. Analysis C, it is nonlinear equation, that is x squared plus y squared is equal to z. But it needs to be, I think, a linear. And D not closed under scalar multiplication, that is scalar multiplication means x, y, and z of z satisfying x, y, z are integers. And therefore, the answer for this one could be alternative B. That's simply this one. It includes 0, and it is also closed under the two basic operations, that's addition and multiplication. Therefore, possible subspace of this one, that is R cubed, will be B, which is x, y, z, where x minus y is equal to 0 and z is equal to 0. Question number 12. The vectors v is equal to 1, 0, 0, v2, 0, 1, 0, and v3 is equal to 1, 1, 0 in R cubed R. Yeah, they can be linearly independent or linearly dependent, basis for R cubed or orthogonal. You know that a set of vectors are said to be linearly independent if and only if any of the given vectors cannot be expressed as a linear combination of the others, or the vectors are linearly dependent, that is, one vector depends on the other whenever any of the given vectors can be easily written as a linear combination of the other. Therefore, for checking the dependence, observe that the third vector, that's simply 1, 1, 0, is the sum of the first two vector v1 and that of v2, which is 1, 0, 0 plus 0, 1, 0. Therefore, this one, that's simply v3, depends on the two vectors, or simply v3 is expressed as a linear combination of the rest vectors, so that these three vectors are said to be linearly dependent. So that the relationship, since v3 is equal to v1, v2, one vector is a linear combination of the other, so that by the definition of the definition for linear dependency, If such a relationship exists, the set is said to be linearly dependent. Therefore, the answer for this one, that's simply V1, V2, and V3 are linearly dependent vectors in Array cubed. So that the correct answer is B. Question number 13. The eigenvalues of the matrix A, that is 2, 0, 0, 3 are. Just we know that in order to find the eigenvalue of n square matrix, we have to find the equation that's simply the characteristic equation, which is the determinant of A minus lambda I, so that the solution of this one could be directly the eigenvalues of the given matrix. Therefore, if 2 minus the characteristic equation could be this one, which is equal to 2 minus lambda times 3 minus lambda is equal to 0, so that the zeros of this characteristic equation could be, since the it is diagonal matrix, for any diagonal matrix, the eigenvalues are simply the entries on the main diagonal, so that the diagonal elements are 2 and 3. Therefore, the eigenvalues are lambda 1 is equal to 2 and lambda 2 is equal to 3. That are the zeros, that is the product will be 0. Either 2 minus lambda is equal to 0 or 3 minus lambda is equal to 0. For 2 minus lambda to be 0, lambda must be 2. And for 3 minus lambda to be 0, lambda itself must be 0. Therefore, 2 and 3, or the diagonal elements of this diagonal matrix, could be 2 and 3. Therefore, the answer is that is A. A, 2 and 3. Question number 14. In the group Z10 plus, what is the order of the element 2? So in order to see this one, let us see a definition of order. The definition of order states that the smallest positive integer n, such that n times is equal to 0 modulus of m. The more it is n, the smallest integer n, such that n times a is equal to 0 or congruent to 0 modulus of m. That means we may have many possibilities for n, or simply may have more than that of one value for n, but we should take the smallest one for n to be the order of the given element. Therefore, if we calculate the possible elements, or simply this one, that's simply 2. The first case, 1 times 2 is 2. 2 times 2 is this one, that's simply 4. 3 times 2 is 6. So lastly, 5 times 2 is equal to 10, which is this one. Therefore, this one, that's 5 times 2, which is equal to 10, is congruent to 0 modulus of 10. And therefore, the smallest element, that simply 5, is the smallest integer, which could be considered as the order for the element, which is 2. Therefore, the order is 2. I mean, the order is 5. Therefore, the alternative for this one could be, that is B. Question number 15. The rank of the matrix A, 1, 2, 3, 0, 0, 0, 0 is blank. We know that in order to know the rank of the given matrix, one best application or simply procedure that must be done is that we have to convert or simply find the given matrix, that's simply the rank of the given matrix, the number of non-zero rows in its row echelon form there, so that in order to calculate the rank of this matrix, we need to find its row echelon form. But since the diagonal element for the first one is the 1 and others are 0, simply the given matrix by itself is originally in row echelon form. Therefore, the matrix is already in a row echelon form and it has only one non-zero row. Therefore, the rank of the given matrix is 1. So that the correct answer is C, which is 1. Question number 16. Let phi say that G to H be a group homomorphism. Which of the following is always true? A, phi of EG is equal to EH. Kernel of phi is a normal subgroup of G. Image of phi is a subgroup of H. All of the above. Okay, just to see the detail here. The identity property, by the definition of homomorphism, phi of A, phi of B must be equal with that of phi of AB. Since it is homomorphism, that means setting A is equal to E and B is equal to E proves that phi of E is equal to E. Therefore, A is true. What does A say? That is, this one phi of E is equal to EH. Similarly, the kernel property, the kernel is always a subgroup of a subgroup, and for any G, which is an element of G, and K, which is an element of kernel of phi, phi of GK, G inverse is equal to phi of G, E times phi of G inverse, which is equal to this, the identity element that's simply E, proving normality, so that B also true. Alternative B is also true. Lastly, the image property, the set of all outputs under phi satisfies subgroup criteria. Therefore, C is also true. Therefore, the answer for this one could be, I think, alternative D, which is all of the above. That is, both the identity property, the kernel property, and the image property are satisfied. Question number 17. Which of the following statements is true about iterative method of solving system of linear equations? That is numerical analysis part. So that the alternatives are, they are more effective than direct methods. They always converge to the solution. They are self-correcting methods, all of the above. We know that in order to see the self-correction, iterative methods like Jacobi or Gauss-Seidel method, which are applicable for solving the system of linear equation, are often called self-correcting method because the new expected solution will be better approximate value for the previous one, so that it corrects or simply by itself. It corrects a step by itself, so that it is self-correcting, because the errors in one step is generally corrected in subsequent iterations. The efficiency would be for a very large sparse matrices, that is with a very large number of component equations and number of variables. Iterative methods are typically more computationally efficient than direct methods like Gaussian elimination. Because they are betas. And the convergence will be, while they don't always converge, that is, they may diverge themselves, but there is a criteria for the given system to either to converge or diverge. They are designed to do so under specific condition, that is diagonal dominancy, because the diagonal dominancy, or being the diagonal, the coefficient matrix of the given system of linear equation being diagonal dominant, will be a criteria simply sufficient condition for the given iterative method to converge to the exact solution for the given system of linear equation. Therefore, the answer for this one could be all of the above. That means, in the case of that of iterative methods, they are more effective than direct methods for very large sparse matrix, for example. They always converge to the same solution. It depends, that is, whenever the coefficient matrix is diagonal dominant matrix, they converge. They are self-correcting methods, of course, so that all of the other could be the solution, or simply the better answer. Question number 18. Consider this table. X, the values of X are 0, 1, 2, 3, and their corresponding functional values are for 3, but this one is unknown, and f of 3 is 7. If e minus 1 cubed f of x is equal to 0, then the missing term that is the functional value of 2 within this function. That means is, we know that the operator e minus 1 is the forward difference operator. That's simply this one. They are equivalent. Therefore, the implication that is a third difference, that simply f of x equal to 0 means the third differences are 0, implying that f of x is a polynomial of degree, because the coefficient, this one is the coefficient of the term with the third exponent, or simply a power, so that because it is already 0, therefore there is no any term containing the power of 3, therefore the maximum degree of this polynomial function is 2, so that it is a polynomial function with degree 2. Therefore, in order to find them using forward difference table, we have 0, 1, the values of x here, the functional values of the function is here. Let's assume that the missing term be this one, that's simply y. Then the first difference could be 3 minus 4, or this one, that's simply because it is yn minus 1. Therefore, 3 minus 4 is minus 1. Y minus 3, since it is unknown, it becomes y minus 3. 7 minus y, these are minus 1, 1 minus 3, and 7 minus 1 are the first differences. Similarly, the second differences could be the difference of the first differences. That means y minus 3 minus 1 could be minus 1, y minus 2. 7 minus y minus 3 could be 10 minus twice of y. And lastly, the third difference could be the difference between the second differences, so that 10 minus 2y minus 2 is equal to 12 minus 3y. But what we are informed here is the third forward difference of this function is already 0, so that we can equate this one, or simply we can make this one to be 0. Therefore, from the 0 of this one, that's simply here, to 12 minus 3y, we have 12 minus 3y is equal to 0, which implies y is equal to 4. So that the missing term here is a 4, or simply f of 2 could be approximated to be 4. Therefore, the answer for this one could be B. That is, the best answer is B, which is 4. Question number 19. The linear interpolating polynomial for the data pointers 1, 3, and 4, 6 is, that is, we have 2 pointers here, and we are asked just to find the linear interpolating polynomial for which can fit for this data. That is a function whose functional value at 1 is 3 and at 4 is 6. Therefore, because we do have 2 pointers here, and we are asked just to a linear interpolating polynomial function, or simply linear polynomial function, that means using that of slope-intercept form, the slope which passes through these 2 pointers could be, by definition, that slope could be y2 minus y1 over x2 minus x1, so that 6 minus 3, because there is x2, y2, and this point could be considered as x1, y1, so that 6 minus 3 over 4 minus 1, which is 3 over 3, that is 1. The slope is 1. Therefore, apply point-slope form, y minus 1 is equal to m into x minus x1, which implies y minus 3 is equal to 1 into x minus 1, because the slope is 1, and y can be any arbitrary point, that's simply yx, and y1 could be the first point, that's simply 3. Therefore, y minus 3 is equal to y 1 into x minus 1. Therefore, y is equal to x plus 2 could be the simplified form of the linear interpolating polynomial function, which can fit for these 2 data. In order to check, for example, if you take x to be 1, so that y could be 3, it can fit. And whenever x is 4, 4 plus 2 will be 6, which is this one. Therefore, there is the exact interpolating polynomial over these 2 data. Therefore, the correct answer is A, that is p of x is equal to x plus 2. Question number 20. Using trapezoidal rule with two subintervals, that is n is equal to the value of the integral from 0 to 1, that is the definite integral from 0 to 1 at bx over 1 plus x is here. We are asked, or simply what we are informed here is we are using trapezoidal rule with two subintervals, that's whenever n is equal to 2 from the integral from 0 to 1. Therefore, A here is A is 0, B is 1, and n is equal to 2, so that h could be the difference between the interval divided by 2, that is half, because n is 2 here, so that 1 minus 0 over 2, which is 0.5. Therefore, this one that's simply 0 to 1 could be divided into two non-overlapping intervals, that is x0 is equal to 0, x1 is 0.5, and x2 is 1. Therefore, we know that the value of f of 0 is 1, f of 0.5 is 1 over 5. That is simply directly if we substitute, that is f of x here is 1 over 1 plus x. So that f of 0 is 1 over 1, that's simply 1. F of 0.5 will be 1 over 1 plus 0.5, which is 2 over 3, and f of 1 is 0.5, that is 1 over 1 plus 1. Hence, the formula for this one, that is trapezoidal rule with two subintervals, that's simply whenever n is equal to 2 could be h over 2 into f of x naught, that's simply y naught, plus twice of f of x1 plus f of x2. Then directly, if we substitute these values here, f of x naught, that is f of 0, which is 1, and f of x1 is x1 is 0.5, that is the 1 over 2 over 3, and f of x2, which is 0.5, will obtain this one, which is 0.708, which is an approximation. So when we round off this one to the nearest value, because we have the alternatives here are given into decimal places, so that it could be 0.71. That is when this one is rounded, we can have approximately 0.71. Therefore, the best answer for this question would be A. Question number 21. The order and degree of the differential equation, second derivative of y with respect to x power of 3 plus dy by dx power of 4 plus y is equal to 0 are. We know that order of a differential equation means it is the highest derivative present in the equation. The highest derivative present in the equation. Here, the highest derivative present within this differential equation is 2. And this one is 1, so that 2 could be directly the order of this differential equation. Similarly, the degree of this differential equation means it is the power or exponent of the highest order derivative. The exponent or the power of the highest order derivative. Here the highest order derivative could be first with the higher order derivative could be this one, that is d squared by dx squared, so that the exponent related to that of this derivative is 3. Therefore, the degree of this differential equation could be 3, and the order is 2. Therefore, these two combination will be contained by the first alternative, that is A. So that the order and degree of differential equation, this differential equation will be 2 and 3. Question number 22, again on differential equation. The integrating factor of a linear differential equation, that is dy by dx plus p of xy plus is equal to q of x is e the power of the integral of p of x dx, the integral of p of x dx, e the power of p of x, e the power of the integral of q of x dx. First, let us see what the purpose of the integrating factor for a linear differential equation. We know that the integrating factor is the function that is mu of x that makes the left side of the equation. The left side of the equation means dy by dx plus p of xy. That means equation a perfect derivative of the form dy dx of u of xy. That means we need to find the function of this form, which is perfectly the derivative for the right side of this linear differential equation. Then when we see the derivation, multiplying by mu of x, we want mu derivative of x equal to mu of x times p of x. So that separating the variables, du over u, d mu by over mu is equal to p of x dx. Then integrating both sides, the integral of this one with respect to d mu with ln mu is equal to the integral of p of x. Then when we further simplify, mu of x is equal to e to the power of p of x dx, so that e to the power of p of x dx is said to be the exact integrating factor for this linear differential equation. Therefore, the answer for this one could be a, which is e to the power of p of x dx, could be the integrating factor for this linear differential equation. Here, question number 3, it is again on differential equation. A differential equation m of x y dx plus n of x y dy is equal to 0 is homogeneous if a, m, and n are of the same degree, b, m, and n are linear, m and n are constants, m and n are independent of x. We know that a function f of x, y is said to be homogeneous of degree n. That is, this form of equation is said to be homogeneous of degree n if f of the x ty is equal to t to the power of n f of xy. If this condition is satisfied by this function f of xy, so that this function f of xy is said to be a homogeneous function of degree n. Therefore, the equation requirement for the entire differential equation to be considered as homogeneous, allowing substitution v is equal to y over x. Both m of xy and n of xy must be homogeneous functions of the same degree. Homogeneous functions of the same degree, so that m, n, and r of the same degree could be the answer for this question. So that the correct answer would be A, which is m and n are of the same degree. Simply, they must be the same degree. If the given differential equation is homogeneous, that means. Question number 24. It is linear programming question. If the primal problem is a maximization problem with less than or equal to constraints, its dual problem will be blank. If the primal problem is a maximization problem with less than or equal to constraints, its dual problem would be a maximization problem with greater than or equal to constraint, a minimization problem with greater than or equal to constraints, a minimization problem with less than, a maximization problem with less than or equal to constraints. First, let us see the duality rules. It says the maximum or simple maximum becomes minimum and vice versa. Maximum, if there exists maximum, there will be a minimum. So, or minimum, if there exists a minimum, there will be a maximum, so that the maximum becomes a minimum, or the minimum becomes a maximum. So the constraints less than or equal to in primal become a variable greater than or equal to 0 in dual. And the third one, variables greater than or equal to 0 in primal become constraints greater than or equal to in the dual, that is minimization. So that the conclusion for this one is that a standard maximization primal A standard maximization primal, which is less than or equal to, corresponds to a standard minimization dual greater than or equal. Therefore, the correct answer for this one could be B. That is, the maximization problem is less than or equal to constraints will be a minimization problem with greater than or equal to constraints, because the maximum becomes minimum or vice versa. Question number 25. A function u of x, y is said to be harmonic if it satisfies a Laplace equation uxx, second partial derivative of u with respect to x plus uyy is equal to 0, b ux is equal to uy, c Euler's equation, Cauchy-Riemann equations. So first, let us see what harmonic functions are. Harmonic functions are said to be smooth functions, or harmonic functions are smooth functions that satisfy the second order partial differential equation known as Laplace's equation. A harmonic function are a smooth function, or becomes function smooth functions if they satisfy the second order partial differential equation known as Laplace equation. That is simply this equation. Therefore, the relation to complex analysis, if f of z is equal to u plus iv is analytic, then both u and v are harmonic. If this complex function is analytic, then the real and the imaginary function, that simply u and v, are harmonic functions. And then the verification could be, this requires that the sum of the second partial derivative with respect to each variable equals 0, that is uxx plus uyy is equal to 0, which is Laplace's equation, Laplace second order partial differential equation. Therefore, the answer for this one could be, that is A, which is a Laplace's equation. That means a function u of x, y is said to be harmonic if it satisfies this second order partial differential equation. That's simple Laplace equation. Question number 26. For the function f of z is equal to 1 over z into z minus 2, the point z is equal to 2 is A, an essential singularity, B, a removable singularity, C, a simple pole, D, a not singularity. So let us see them. Definition could be here. An isolated singularity z naught is a pole if of a pole of order n if the limit of z minus z naught, the power of n f of z, whenever z approaches z naught, is a non-zero constant. Here, if we test or simply check, for example, that's simply z, because the isolated singularities here are the function where the function that is f of z is undefined, that is z is equal to 0 and z is equal to 2, so that we are asked that at the point z is equal to 2, so that let's verify this one at the indicated point. So that if we multiply z minus to the power of 1, because n here is that is 1, then we have the limit of z minus 2, that is z minus z naught, that's simple of this form, 1 over z minus z naught, I mean z2, is equal to the limit of 2 times 1 over z, is equal to 1 over 2. 1 over 2, because z minus 2 can be cancelled by this one, that's simply z minus 2. So what's left here is only 1 over z. Therefore, the limit of this product becomes the limit of 1 over z whenever z approaches 2, and this could be 1 over 2, which is different from that of 0, simply non-zero. Therefore, the conclusion could be, since the limit is a non-zero finite value for n is equal to 1, it is a pole of order 1, also known as simple pole. Just we have said here, an isolated singularity z naught is a pole of order n if the limit of z minus z naught the power of n, f of z whenever z approach z naught is a non-zero constant ከሆነ ብለናል። ስለዚህ ይህን ስላገኘን it is a simple pole. Therefore, the answer for this one could be a simple pole, that's simply C, which is a simple pole. Question number 27. If H and K are subgroups of a group G, then H intersection K is A, always subgroup of G, never a subgroup of G, a subgroup only if H is the subset of K, a normal subgroup always. Here, let us see the subgroup criteria, the criteria for a given group to be subgroup. It must satisfy identity, closure, and inverse. The next one, that's simply identity. The identity that is it is an element of H, that is if is an identity of this one that's simply H and is also an element of K, then E must be the within the intersection of this one that is H intersection K, and it is closure T if AB is an element of H intersection K. So that because of from the definition of that of intersection, both A and B must be an element of H, so that AB is an element of H. Similarly, AB is also in K. That AB is in H and K, that is H intersection K. Then when we see the inverse, that is the last necessary condition for this group to be a subgroup. If A is an element of, or simply within H intersection K, then A inverse must be in H, and A inverse must also be in K. So A inverse must be an element of H intersection K. Therefore, unlike the union, the intersection of any collection of subgroup is always a subgroup. The union, the intersection of, unlike the union, the intersection of any collection of subgroup is always a subgroup. So that the answer for this one could be, that is A, it is always a subgroup of G. Question number 28. Which of the following sets is uncountable? First, let us see what an countable and uncountable set is. Countability, a set is said to be countable if there exists a bijection with set of natural numbers, or a given set is said to be countable set if there exists a one-to-one correspondence, that is, with respect to the number of elements of the given set and set of natural numbers. So that when we analyze n, z, and that of q, or n, the set of natural numbers, the set of integers and set of rational numbers are all known to be countable sets because there exists a one-to-one correspondence with respect to the set of natural numbers. Each of these set of numbers have a one-to-one correspondence or can satisfy bijection with this one, that's simply n. Therefore, the Cantor's diagonal argument, Cantor is an individual, which proves this one, that simply this proof showed that the set of real numbers and any interval with it like 0 to 1 cannot be put into a one-to-one correspondence with n. So that if this set of numbers in between 0 and 1 cannot be put into one-to-one correspondence with n, so that this set is said to be uncountable set. Therefore, the intervals of real numbers have the cardinality of continuum C, which is uncountable because there is no any one-to-one correspondence with respect to the set of natural numbers. Therefore, the answer for this one is that simply C, the interval there 1 in R is uncountable set. Question number 29. In a discrete topology on a set X, every subset of X is open only, closed only, both open and closed, neither open nor closed. So let us see this definition first. In a discrete topology, the topology tau is the power set, the power set of X, the power set of X. Then when we see the openness, by definition, every subset is in tau, so every subset is open. That is, if in definition that's simply in a discrete topology, the topology tau is the power set of this one, that simply is power set of X. So that if every subset in tau, so every subset is becomes open, or simply it becomes open set. When we see the closedness, a set is said to be closed if its complement is open. Since the complement of any subset A is X without A, which is also a subset of X, so that the complement is open. So therefore, the conclusion will be every subset is also closed. Such sets are often called Klopen. That means Klopen sets are sets whose subset is closed. Whose subset is closed. Therefore, the answer could be that is C, both open and closed. Open and closed sets. Question number 30. If G is a finite group and H is a subgroup of G, then A, the cardinality, or simply the cardinality of H divides G, this G divides this one, that is H. So let us see this theorem first. This is a fundamental Lagrange theorem in finite group theory. That means step one, the coset, the left coset of H in G, partition G. This means every element of G belongs to exactly one left coset. Similarly, equal size, H coset GH had the same number of elements as H. There is a bijection in between f of H and G of H. And third, counting, if there are k discrete cosets, then the number of elements of this one, that is G, is equal to k times number of elements of H. So that the conclusion will be, since k, the index of H in G, must be an integer, the order of the subgroup, the order of the subgroup, that's order of H, must be a divisor of the order of group G, the order of group G. So that the correct answer for this one could be A, that is the order of H divides order of G. Question number 31. Let S is equal to 1 over n times 1 over n such that n is an element of n. Then the supremum of S is. In order to answer this question, we have to know what supremum is. Supremum is the maximum element of this set, that means. So that it is given like 1 over n whenever n is a natural number. So that the elements of this one could be, whenever n is 1, we will obtain 1. Whenever n is a second natural number, that's simply 2, we will obtain 1 over 2, 1 over 3, 1 over 4. It goes on this pattern. So that the maximum element or the supremum element of this one is the first element of this set, which is obtained whenever n is equal to 1, which is 1. Then by definition, the supremum is the least upper bound of the given set. That is, the least upper bound would be, the upper bounds are from 1 to that of positive infinity, so that the least element is 1. Therefore, all elements in the set are less than or equal to that of 1. Then 1 is an element of the set, that simply which is obtained whenever n is equal to 1. since 1 is an upper bound and it belongs to the sets, so that it must be the least upper bound. The least upper bound. Therefore, the answer could be, that is the correct answer is B, which is 1. 32. Let X is equal to the set containing ABC. Which of the following is a basis for a topology on X? Basis of the topology of this one, that's simply X. So first, let us see this definition. The definition could be a collection B is a basis if these two conditions are satisfied. The first condition is the union of elements in B is in X. The intersection of any two basis elements in a union of basis elements. So that when we check these two elements for the given set is here. For B, for example, that's simply this one, the set containing the sets that is A and B and C. So the elements, the first element, that's simply A union. Second element could be ABC, that is, which is X. And their intersection is empty set, which is a trivial union. This satisfies the conditions, that is, these two conditions. And if we check C, A, B, intersection BC is equal to B. However, B is not within the element of the base, that's simply which is here. Therefore, it fails to satisfy the second condition. Second condition, that's simply condition 2. Therefore, the answer could be, that is this one, which is B. That is B, I mean alternative C, which is the base B is equal to set containing the element that is set containing AB and set containing B and C. Question number 33. The sequence n is equal to minus 1 the power of n over n is, will it be divergent, convergent, convergent to 1, or unbounded? We know that the given sequence is said to be convergent if the given sequence is, that is the limit of the sequence is existing at infinity, I think. So anyways, let us see this one. You know that when we evaluate the limit of minus 1 the power of n over n at infinity, it is just by using that of a squeezing theorem, because at infinity it oscillates in between negative and data positive. So that observe that this one minus 1 the power of n over n is sandwiched in between minus 1 over n and positive 1 over n. Then the limits of the endpoints of this one, that is minus 1 over n at infinity is 0, and 1 over n is also 0, so that the sequence must be converged to the same number. That is, the limit of minus 1 the power of n over n must also be existing and equivalent to that of 0. Therefore, the answer could be it converges the sequence, it converges to its limit at infinity. Therefore, the correct answer is B, which is convergent to 0. Question number 34. Which of the following is not an integral domain? First, let us see what an integral domain is. We know that an integral domain is a commutative ring with identity and no zero divisors. A commutative ring with an identity and without any zero divisor is said to be an integral domain. And therefore, zero divisors, elements that simply in A and B different from that of 0, such that A dot B is equal to 0. For example, if we check Z6, and Z6, 2 is different from that of 0, and 3 is also non-zero. But 2 times 3 is equal to 6, congruent of 0 modulus of 6. Therefore, the conclusion could be, because Z6 has 0 divisors, because of this one, it cannot be an integral domain. Therefore, from this alternative, the one that cannot be an integral domain could be, that means which is not a commutative ring with identity and has no zero divisor, could be this one, that is which is C. Question number 35. The function f of x equal to x squared is uniformly continuous on. This quadratic function is uniformly continuous on 0, 1, 0 to infinity, on R, none. We know that f is said to be uniformly continuous if for every epsilon positive, there is delta positive, which is independent of x. Therefore, in case A, that is simply within 0 to 1, bounded interval, a continuous function on a bounded interval AB is uniformly continuous if its limits at the endpoints exist and are finite. A continuous function on a bounded interval AB is uniformly continuous if its limits at the endpoints exist and are finite. So when we check this one, that's for f of x equal to x squared over 0 and dot of 1, limit of x squared at 0 is 0, and limit of x squared at 1 is 1, which is finite and exists. But the end that of z, they are unbounded on R. As x gets larger and larger, the slope to x increases without any bound, meaning for a fixed E, the required data becomes infinitely small. Or even the limit may not existing. Therefore, the conclusion will be, therefore, x squared is uniformly continuous on a bounded intervals like 0 to 1, but not 0 to infinity or R. Therefore, the answer is that is the first one, that is A, 0 to 1. Question number 36. Which of the following subspaces of R with standard topology is connected? A, closed interval from 0 to 1 union to 3, set of rational number, open interval 0 to 1, and set containing 0 and 1. So let us see this property first. In the real line R with the standard topology, a subspace is connected if and only if it is an interval. And therefore, when we analyze the first one, that's simply this interval, the union of these two intervals, this is a union of two disjoint closed sets, which is not an interval, unless B, set of rational number, is totally disconnected between any two rationals, is an irrational number, or simply because of the existence of irrational numbers. Q is totally disconnected, so it is not connected. C from 0 to 1 is an interval. It cannot be split into two non-empty disjoint open sets. Therefore, and the last alternative, that's simply D, containing the set containing only 0 and 1. It is discrete set with 2 pointers clearly disconnected. Therefore, the answer could be, that is C, which is 0 to 1. Okay, thank you. That is all what I have for today.